Hello, welcome to the last unit of Learn at Home, Unit 5. Probability distributions and predictions, specifically 5.1, probability distributions and expected value. Let's put the date, Friday, June 5th. Okay, two goals. Define discrete random variable, define probability distributions and expected value. Note number 1, a discrete random variable is a variable that has a specific value for each outcome. Okay, this value must be countable without decimals. That's why it's called discrete, right? So no decimals if you have a discrete value. Each outcome must also be random, hence the word in the term. Variable means it takes on different values, okay? So for example, rolling a die is a discrete random variable because each outcome is random and each outcome has a specific value, okay? Example 1, roll 2 6-sided die for 15 trials. Determine the sum for each roll. Record the sum in the table on the left. This table is called our frequency distribution. So if we had 2 die and we were in class, we would be doing this together and everybody would be working in pairs, but we are not in class. So I've just taken these values from a class in a previous year, okay? So what would have happened is 2 die, everybody, a pair of two students would each roll their die, they'd add the sum together, and so they'd represent pair 1, pair 2, pair 3. So we'd have everybody spoken for, and so they would get these various sums. Okay, so we've done part A here. We want to now in B, so this is A, okay, so record the relative frequency of each sum in the table on the right. So relative frequency is the number of times the desired event occurs all divided by the number of total trials. That probably sounds familiar, right? Okay, a sum of 2. Did we get a sum of 2 anywhere? I don't think so. Okay. 3. No. 4. Okay, so we had this one here and we had this one here. Okay, so it was 2 times out of 15 in total. So 2 out of 15, 5. So here, 1, 2. Okay, so 2 out of 15, 6. 1 here. That's 1. Okay, so 1 out of 6. 7. 1 here. Second one there. Oops. Okay, out of 15 because we had 15 trials in total. 8. 1. 1. 2. So 2 out of 15, 9, so 1, 2, so 2 out of 15, 10, 1, 2, 3, so 3 out of 15, 11, I don't think we saw 11 here, so that's 0, and then 12, we saw the 1 time. Okay, so that's relative frequency. All right, so that was B. Graph your sum on the x-axis and the probability on the y-axis. So x equals sum and y is probability. Okay. This is going to feel a bit like deja vu because we have done this before when we talked about histograms back in elementary school, but in grade 9 and in unit 1, but also when we did it in unit 3. What's going to change as like it did in unit 3 is that we will not have a space between our x values. So even though they're not decimals, we're going to throw that rule out the window and we're going to keep them side by side. Okay, so we are going to start with a sum of 2. It doesn't matter in this case if we start right at, quote 0, 0 or at 0 here. So if we leave a space, it might be a little bit more natural to do 2. But if you don't leave a space, again, it's not going to make a big difference. So there's going to be 2. The sums are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then our probabilities, because they're all a denominator of 15, we do not, should not, will not convert them to a decimal. It's not necessary. So here, this is 1 out of 15. This is 2 out of 15. This is 3 out of 15. And then I think that's it. Okay. So for 2, there's nothing here. 3, there is nothing. 4, it's 2 out of 15. 5 is 2 out of 15. 6 is 1 out of 15. 7 is 2 out of 15. 8 is 2 out of 15. 9 is 2 out of 15. 10 is 3 out of 15. 11 is 0, and 12 is 1 out of 15. Oops, 1 out of 15. Okay, so that is our probability distribution. Okay, so note number 2, relative frequency, which is what we did up here. The number of times the event has occurred. So we talked about event meaning a desired event, desired outcome or event. Has occurred divided by the number of trials. Relative frequency is also called experimental probability. Okay, so thinking back to unit 4, after enough trials, the relative frequency is equal to the theoretical probability. Okay, and we're going to see what does theoretical probability look like when it's graphed. All right, so the probability distribution, which is over here, of a discrete random variable x shows the probability of each possible value of x using an equation, a table, and a graph. These probability distributions are functions. Okay, so this is a little bit weird to get our head around, but if we want to talk about a discrete random variable x, we could talk about the sums having assigned values. Okay, so for each sum it would have a value which was equal to its sum. Okay, and the likelihood that it would occur is its probability. So when we want to talk about this, okay, in more detail, we're going to talk about an equation, a table of values, and a graph. Now you might not think this is completely understandable, but I want you to think about a linear relation. What did you talk about in grade 9? You talked about a linear relation shown using, number 1, an equation, y equals mx plus b. Okay, a table of values. Right, X and Y. And then the third thing was a graph. Right? So this is not really that far off from what you did in grade 9. Okay, it's a little bit different, but it's relatable. Okay, example 2a. Determine the possible sums from rolling 2 six-sided die. Okay, if we want to do that, let's set up a chart. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Die 1, die 2. So let's do the sums. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. And then 5, 6, 7. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. Then 6, 7, 8. Then 3 plus 1 is 4. 3 plus 2 is 5. Then 6, 7, 8, 9. 4 plus 1 is 5, 4 plus 2 is 6, then 7, 8, 9, 10. 5 plus 1 is 6, 5 plus 2 is 7, then 8, 9, 10, 11. Then 6 plus 1 is 7, 6 plus 2 is 8, 9, 10, 11, 12. Okay? So we are going to determine the possible sums. They're based on theoretical probability. Why? Because they're unchanging, okay? We're going to represent the probability distribution for this discrete random variable using a table of values. Here's our table of values, okay? Here's our possible sums. All right, so how often did we get a sum of 2? We just got it once. Out of 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 by 6 is 36. So we got it as 1 out of 36. Okay, what is the theoretical probability? It's the number of desired outcomes divided by the total number of outcomes. If you say this is similar to what we did in Unit 4, you are correct. 3, we got it once and twice, so we got that at 2 out of 36. I'm not going to reduce these, and I'm going to show you why. So 4, 1, 2, 3, so 3 out of 36. 5, 1, 2, 3, 4, so 4 out of 36. 6, sum of 6 was 1, 2, 3, 4, 5, so 5 out of 36. What else? 7, 1, 2, 3, 4, 5, 6, so 6 out of 36. 8, 1, 2, 3, 4, 5, so 5 out of 36. 9, 1, 2, 3, 4, 4 out of 36. 10, 1, 2, 3, 3 out of 36. 11, 1, 2, 2 out of 36. 12 is 1 out of 36. Okay? The reason I don't reduce is that when I go over here to do my graph, is I won't be able to go up by a consistent number because I'm going to be looking at the fact that one of them, that would be out of 18, right? That would be out of 18, right? And well, technically that would be out of 9, right? So I don't want to do that. There's no point in that. So in C, represent the probability distribution for this discrete random variable using a graph. This is our graph. It's a bar graph or a histogram. Okay, let X represent each sum and Y represent the probabilities. Okay, so I've got probabilities that go up to 6. So this is 1 out of 36. This is 2 out of 36. This is 3 out of 36. This is 4 out of 36. This is 5 out of 36. This is 6 out of 36. Okay, If I wanted to, I could skip every other and label 2 out of 36, 4 out of 36, and 6 out of 36. Okay, like I said on the page 1, we're not going to separate, so I don't have a sum of 1, but I do have a sum of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I got a sum of 1 out of 36. Sorry, I have a sum of 2. The probability of that happening was 1 out of 36. 3, 2 out of 36. 4 was 3 out of 36. 5 was 4 out of 36. 6 was 5 out of 36. 7 was 6 out of 36. 8 was 5 out of 36. 9 was 4 out of 36. 10 was 3 out of 36. 11 was 2 out of 36. And 12 was 1 out of 36. Now, if you stop there in awe and go, oh my goodness, this looks like a normal curve, you would be correct. Yes, you would be. Okay? Deja vu. Okay. Find the probability that you have a sum that's less than or equal to, less than or equal to, okay? Less than or equal to 7. So what do we have? We have sums that are less than or equal to 7. So that would be D, these would all be D, right? So I'd have the sum of my probabilities. So I'd have 1, they're all denominators of 36, so I can just add them. So 1 plus 2 is 3, plus 3 is 6. Plus 4 is 10, plus 5 is 15, plus 6 is 21 out of 36. Could divide by 3 here, so it equals 7 over 12. We could also look here and we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And that's what we got. Okay, so 7 out of 12 when reduced. Find the probability that the sum is even and, so this is both, okay, the sum is greater than 7. So I could go, okay, so sum is greater than 7. So sum is greater than 7. Okay, so that's E. Okay, sum is greater than or equal to 7. Okay, so this is greater than or equal to, right? So, but it has to be, the sum has to be even, okay? So that's greater than or equal to. So I have an overlap here. Okay, so this is all E, right? All E, but it has to be even. So it's here, here, and here, right? So you'd go 5 plus 3 is 8, plus 1 is 9. So 9 out of 36, divide by 9, so you'd get 1 out of 4, okay? If you wanted to greater than or equal to 7, but it has to be even, so there'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, which is what we had over here to reduce, okay? All right, note number 3. The sum of the theoretical probabilities always equal 1 for all discrete random variables. So if we added all of these, 1 plus 2, so if we add these the denominator is 36, so we rewrite the denominator of 36, but we add. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, it equals 36. Okay, so it equals 36 out of 36, so it's equal to 1. All right. Here comes a very strange, odd, complicated looking formula, but believe me, it's not going to be all that complicated once we get through it. Okay, note number 4. The expected value of a discrete random variable x is the sum of the terms of the form x times the probability of x for all possible values of x. So just hold on until we get to the end. Let x represent the values of x1, x2, x3, all the way up to xn, where n is the value of the last term. Then the expected value of x is given by the expected value e, where the value of x is multiplied to the value of the probability when x is specifically 1, plus when x is 2 times the probability of the expected value being 2, plus when x is 3 times the probability when the discrete random variable is equal to 3, and then so on. Now, it's all simplified into something that looks even more complicated, where n represents the number of terms of the sum, in the sum. Now, we are going to turn all of that into something that we can completely understand using a table of values, okay? So we're going to apply formula using a table of values. Okay, so trust me when I say this weird formula, okay, so this is the equivalent to that, okay, which is also the equivalent to this. Okay, so there are 1, 2, 3 versions of the same thing. All right. Okay. Suppose you tossed 4 coins, find the expected number of heads. So we're going to do our picture here. I'm going to do it left to right because it's a little bit easier to figure out. So there's my start. Okay, so I get head, I get a tail. Here I get a head or I get a tail. Already moving this down. Okay, so then I get a head or I get a tail. Okay, so I'm going to stop. So this is the outcome for coin number 1. This is the outcome for coin number 2, right? Okay, so then from coin number 2, I get a head or a tail. I get a head or a tail. Oops, let's move this down a little bit. Okay, so 1. So from here I get a head or a tail, and here I get a head or a tail. So this third row set of branches is for number 3, coin number 3, and then I get a head or a tail. 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 It's getting tight. I get a head or a tail. I get a head or a tail. I get a head or a tail, and I get a head or a tail. Okay, so here I get head, 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 head. Here I get a head, head, head,